Hello, and welcome to the Sleepless Scientist. Tonight we'll explore one of the most daring and delicate questions physics has ever whispered into the night sky: the multiverse. If these journeys bring you peace, feel free to like and subscribe. Tell me where and what time you're listening. It's like stars across one sky, scattered but connected. So dim the lights, let the world fade, and let's begin. If you lose the thread, don't worry. It will be here waiting. Are we living in just one bubble among countless realities? The question sounds almost like something from a bedtime story, or perhaps from a dream you half remember in the morning, where doorways opened into impossible landscapes and every choice led to another path. And yet, remarkably, this question is not confined to myths or novels. It sits on the desks of cosmologists and philosophers, on chalkboards filled with equations, in observatories gazing into the cosmic afterglow, and in the quiet minds of people like you, lying awake and wondering whether this vastness we call the universe is all there is. For most of human history, the idea of everything was simple enough. You looked up at the night sky, you saw stars scattered like crumbs of light, and you thought, this is the universe. A dome overhead, maybe infinite, maybe not, but self-contained. The word universe itself means all that there is. It seems almost contradictory to suggest that there could be more than one. After all, how can there be multiple alls? And yet modern physics, with its peculiar blend of precision and poetry, has arrived at a place where the possibility of other universes arises not from fantasy, but from the equations themselves. The idea comes in many flavours, each one like a different doorway in a long, quiet hallway. Some doors open to the concept of infinite regions beyond what we can see, like knowing the horizon is not the end of the ocean, just the limit of our sight. Others lead to worlds born from quantum decisions, where every coin toss, every choice, every flicker of possibility creates a branch, as if reality were a forest where paths endlessly divide. Still other doors lead to landscapes predicted by string theory, a garden so vast that the laws of physics themselves could differ from patch to patch, like flowers of every colour imaginable. But before we wander through these corridors, before we peek into these possible worlds, let's pause at the threshold and reflect on the word itself, multiverse. A simple coinage, multi for many, verse for universe. But behind it lies a shift as profound as any in human thought. To accept the possibility of a multiverse is to accept that our universe, with its galaxies, stars, planets, oceans, and you, yes, you, listening in the dark, is not the entirety of existence. That we might be one bubble in a foam of countless bubbles, one page in a library without end. It is at once a humbling and a liberating thought. Humbling, because it reminds us that our cosmic home, immense as it feels, might be only a small neighbourhood in a much larger city of realities. Liberating, because it suggests that reality is not a single thread, but a vast tapestry, with colours and textures far beyond what we can imagine. And if that tapestry exists, then every possibility, every variation, every tune the universe could play is playing somewhere, somehow. To some, this sounds dizzying, almost frightening. To others, it is comforting. The idea that somewhere, beyond the veil of our horizon, other worlds are unfolding, other histories are being written, other stars are burning. But tonight, we won't rush to conclusions. We will take it slowly, gently, one step at a time. Like following a path lit by lanterns in the dark, we will pause at each light, look around and move on when we're ready. We'll begin with the cosmic horizon, that quiet edge of what we can see, where the universe itself falls into silence. Then we'll explore the inflationary story, where bubbles of space may sprout like foam. We'll walk through the forest of quantum branching, where every possibility has its place. we'll wander the gardens of string theory, where laws themselves are blossoms of possibility. Along the way, we'll meet the anthropic principle, that curious notion that our universe looks just right, because only certain universes can host beings to ask such questions. We'll glimpse the attempts to find evidence, patterns in the cosmic microwave background, strange alignments in the sky, hints that might or might not be real. And we'll join the debate itself. Is this science or speculation? Do these ideas illuminate, or do they blur the line between physics and philosophy? And finally, we'll reflect on what it all means for us. Because even if we cannot yet prove the existence of other universes, the very act of imagining them reshapes how we see ourselves. Are we unique, or are we common? Are we central, or are we peripheral? And does it matter if we are still here, breathing, thinking, sharing a moment across the vastness of space and time? As you settle deeper into your pillow or your chair, let your mind wander as freely as it wishes. If you drift off, let the questions drift with you. The multiverse is, in a way, the perfect bedtime story. It is vast enough to hold every dream, soft enough to fade into sleep, mysterious enough to welcome you back tomorrow with new wonder. So tonight, let's open the first door, gently, slowly, with curiosity and calm. Somewhere beyond the stars, perhaps beyond what any telescope will ever see, there may be other worlds unfolding. But here, for now, is enough. You, me, and the quiet question. Are we alone in this universe, or are we one among many? When we talk about the multiverse, one of the first and simplest ideas begins not with exotic mathematics or tangle theories, but with something so ordinary that you can see it whenever you step outside: a horizon. On Earth, the horizon is the line where sky meets ground or sea, the edge of what you can see from where you stand. You know, of course, that the world doesn't end there. Beyond that line, hidden from your view, there are more fields, more trees, more waves rolling in on another beach. But your eyes can only carry so far, and so the horizon feels like an ending, even though it never really is. The cosmos too has a horizon, and for cosmologists this horizon is the first quiet invitation to imagine that our universe might be larger, far larger than what we can observe. The cosmic horizon is not made of stone or mist, it is made of time and light. Light travels at a finite speed, swift and steady, but not instantaneous. That means there is only so much of the universe whose light has had time to reach us since the beginning, roughly 13.8 billion years ago. Beyond a certain distance, about 46 billion light years in every direction, there simply has not been enough time for light to arrive. We cannot see farther because the signal has not yet been delivered, and so, just as a sailor in the ancient world saw the edge of the sea and wondered what lay beyond, we look at the cosmic horizon and ask ourselves, what is on the other side? This question may sound poetic, but in physics it is sharp and practical, because the equations we use to describe the universe do not suddenly end at that distance. The mathematics suggests that space continues, perhaps infinitely. The galaxies we see may only be a small patch of a much larger quilt, each square repeating in patterns, or diverging in ways we cannot yet know. Imagine standing in a vast meadow on a foggy morning. You can see a circle of grass and wildflowers around you, but the mist hides everything farther away. Your senses tell you only about this patch of meadow, but your reason insists that the meadow extends beyond the fog. That is, in essence, what cosmologists mean when they speak of the observable universe. If the universe is much larger than the part we can see, then it is possible, even likely, that regions beyond our horizon are not identical to ours. The laws of physics may be the same, but the arrangement of matter may differ wildly. Some regions may have galaxies more densely packed, others may be almost empty, like deserts in space. Still others may have stars forming in different ways, clusters shaped in unfamiliar patterns, or no stars at all. Each region would be inaccessible to us, forever beyond reach, but real nonetheless. To call such a picture a multiverse is perhaps stretching the word, because technically it is still one universe, one continuous space, but sliced by horizons into isolated realms. Yet for a being like us, confined to one horizon's view, those distant patches might as well be separate universes, for we will never touch them, never trade light with them, never know them. There is a curious comfort in this thought. If you have ever looked out from a hilltop or an airplane window and realised that what you can see is only a fraction of the Earth, then you have felt a similar smallness. You know there are people going about their lives in cities and villages beyond your sight, children laughing, families eating, lights flickering in houses you cannot see. Their existence does not depend on your seeing them, but your imagination brings them to life. The same is true when we think of cosmic horizons. Whether or not we can ever observe those regions, the mathematics suggests that they exist, and our imagination supplies the rest. The horizon also carries a kind of paradoxical beauty. The farther we look into space, the farther back we look in time. A galaxy seen 1 billion light-years away is seen as it was 1 billion years ago. The edge of our observable universe is not only a limit in space, but also a limit in time, the farthest past we can glimpse. Beyond it, the past continues, but it is hidden from us. So the cosmic horizon is both a boundary and a mirror, telling us about what is possible and reminding us that we are small, but not alone in our smallness. Physicists sometimes call the cosmos beyond our horizon the unobservable universe, which sounds clinical, almost dismissive, but in truth it is an arena for the most expansive dreams. If space is truly infinite, then somewhere beyond our sight there may be regions that look astonishingly like our own. Perhaps there is another Milky Way, another Earth, another version of you listening to a bedtime story about the multiverse, marvelling at horizons. In an infinite space, patterns repeat. Just as a long string of letters will eventually spell out every word, an infinite cosmos could eventually arrange its matter into every possible configuration. That thought is dizzying, and perhaps a little absurd, but it follows from the same simple principle that began with the horizon. What we see is not all that is. Still, horizons remind us of humility. We cannot cross them, at least not with any technology we can imagine. We cannot peer beyond them with telescopes, no matter how sharp. The horizon is not an invitation to travel, but an invitation to imagine. It says, here is the edge of your vision, but not the edge of existence. And so, we sit at the shoreline of the cosmos, looking out at an ocean whose waves we'll never see, and we wonder. In this way, the cosmic horizon is the gentlest form of the multiverse idea. It does not require new physics or bold speculations. It only requires us to accept that what we see is not the whole. For some, that alone is enough. For others, it is just the first step. Because if a horizon suggests other regions, inflation suggests other worlds altogether, bubbling into being in the deep fabric of space. But before we drift there, let's linger here for a moment longer. Let your thoughts stretch to the edge of the visible universe. Picture galaxies like lanterns fading into mist. Picture the silence beyond, the vastness that holds everything we know and everything we do not. The horizon does not end the story, it begins it. The story of the multiverse often turns from horizons to something stranger, something that happens not at the far edge of space, but in its earliest heartbeat. To understand it, we have to imagine the universe not as it looks now, with galaxies scattered like luminous grains across darkness, but as it was in the very beginning, when everything we know was compressed into something smaller than a grain of sand. In those first instants, according to modern cosmology, space itself did not simply expand. It inflated, sudden, violent, and faster than the speed of light. This is not faster in the ordinary sense of running more quickly than a car or a beam of light. It is space itself stretching so swiftly that distance is doubled and doubled again in unimaginably tiny fractions of a second. This idea is known as cosmic inflation, and it is one of the most powerful explanations for how the universe we see today came to look so smooth, so uniform, and yet sprinkled with the right irregularities for galaxies to form. But like many good ideas in physics, inflation carries a twist. If space can inflate once, why not keep inflating? Some versions of the theory suggest that while inflation may have ended in our patch of space, it never truly stopped everywhere. Instead, it continues eternally, in a ceaseless blossoming of new regions. Picture a pot of water set to boil. At first the surface is flat, then bubbles begin to appear, each one forming and separating, each with its own interior space. That, cosmologists say, might be the true shape of reality, a cosmic bubble bath where each bubble is a universe, swelling and drifting in an endless froth. Inside one bubble, like ours, inflation has ended, allowing stars, planets and life to appear. But outside, the pot is still boiling. New bubbles form without end. Some may be almost identical to ours. Others may be utterly alien, with different arrangements of matter, different laws of physics, even different numbers of dimensions. We cannot reach them, just as one bubble of soap cannot merge with another without bursting, but they exist side by side, forever separate. This vision of eternal inflation is one of the most vivid pictures of the multiverse, and one of the most haunting, because it suggests that creation is not a single event but an ongoing process. The appeal of this idea is not only imaginative, it helps answer puzzles about why our universe looks the way it does. Inflation explains why the cosmic microwave background, the afterglow of the Big Bang, appears so uniform across the sky. It explains why space is so flat, as if stretched taut, but eternal inflation goes further. It suggests that what we call the universe is just one region where inflation happened to end. Elsewhere it continues, pushing into new directions, creating universes with their own stories. Physicists like Andre Linde, one of the architects of the inflationary theory, have described this picture with both mathematical seriousness and almost childlike wonder. In his vision, eternal inflation is like a tree that never stops branching, each twig a new cosmos, or like a vast ocean forever spawning bubbles of foam, each bubble sealed off, each containing its own time, its own galaxies, its own possibilities. For us, living within one bubble, the rest is forever beyond reach. The boundary of our universe is not a wall, but a separation of histories. To cross into another bubble would be impossible, for the space between them is still inflating, growing faster than light can travel. It is as if each bubble is carried away from the others on an ever-accelerating tide. No ship, no rocket, no dream of engineering could bridge that divide. And yet, just knowing that the possibility exists, that beyond our visible universe, beyond even our cosmic horizon, there might be countless other realms, changes how we think of our place in the cosmos. Everyday images can help soften the strangeness. Imagine being in a bathtub filled with soap bubbles. Each bubble is thin and fragile, yet inside each one is a whole shimmering world, reflecting rainbows on its curved surface. Now imagine that instead of soap film, each bubble is made of space and time, expanding within itself, vast beyond comprehension. The froth stretches on forever, more bubbles always forming, the bath never running dry. That is eternal inflation as told by physics, a bath drawn by the universe itself, still steaming with creation. If you prefer another picture, think of a loaf of bread rising in the oven. Yeast produces bubbles of air that expand, each pocket inflating until the loaf is full of them. Now imagine that each pocket is not just air, but an entire cosmos, a universe sealed inside a bubble of dough, complete with its own laws of physics, its own galaxies, its own listeners lying awake, wondering if they too are only one bubble among many. Some find this vision exhilarating, others find it troubling. It raises questions about uniqueness. If there are countless universes, does that make ours less special? Does it diminish the wonder we feel when we look at the night sky, knowing it is only one of many skies? Perhaps not. Perhaps it is the opposite. Just as every snowflake is unique though countless fall, every universe may hold its own form of beauty, its own fleeting patterns, its own music. Our universe, with its particular laws and histories, is ours to cherish, even if there are infinitely many more. In the quiet of the night, eternal inflation feels less like a scientific model and more like a lullaby of abundance. Creation did not stop in a single burst. It continues endlessly like a fountain that never runs dry. Somewhere, even now, new universes may be blooming, unseen, unreachable, yet real. And while we may never touch them, the thought itself is enough to widen the imagination, to stretch the heart, to remind us that reality is always larger than what fits within our view. So, as you drift deeper into this story, picture the bubbles rising, picture the foam spreading, picture the pot that never boils over but never cools, forever alive with motion. Eternal inflation, the cosmic bubble bath, is not a certainty, but it is a possibility drawn from the mathematics of the very early universe. And in that possibility lies a vision as strange as any dream, that the cosmos is not one, but many. Not a single flame, but a firework that never stops exploding, lighting realities we will never see, yet can imagine in the soft darkness of the night. If eternal inflation gives us the image of a bubble bath forever frothing, then the next step in our quiet journey is to consider what might be inside those bubbles. After all, if each one is its own universe, it is natural to ask, are they all the same, or could they be different, stitched with variations like squares in a vast quilt? Cosmologists often imagine that eternal inflation not only produces countless universes, but also allows them to be unique, with their own physical constants, their own rules, their own cosmic personalities. And so the metaphor of a quilt feels fitting, a sprawling patchwork that stretches without end, each square distinct, but together forming a larger fabric. To appreciate this idea, think first of the laws of physics as we know them. Gravity pulls you to the ground, light travels at a fixed speed, atoms arrange themselves according to the periodic table, stars burn by fusing hydrogen into helium. These seem immutable, almost like the grammar of reality. Yet the strange suggestion of the multiverse is that these rules might not be universal after all. In another bubble, gravity could be stronger or weaker, atoms might assemble differently, stars might not form at all. Imagine two recipes for bread, one with just the right amount of yeast, the other with too much or too little. One loaf rises perfectly, another collapses into a dense lump. Another swells too quickly and bursts. In the cosmic kitchen, each bubble of the multiverse could be a different recipe, with its own outcome. Physicists sometimes frame this in terms of constants, numbers that seem baked into the fabric of our universe. The strength of the electromagnetic force, the mass of the electron, the cosmological constant that drives cosmic acceleration. In our universe, these numbers are what they are, and because of them, chemistry works, stars shine, and life is possible. But why those numbers and not others? Inflationary theory suggests that different bubbles could freeze in different values when inflation ends, just as a quilt might be stitched with a new colour or pattern for each patch. Some bubbles would be sterile deserts, unable to produce complexity. Others might be violent, their physics too unstable for anything to form. And a few, perhaps a rare few, might look something like ours, balanced in such a way that galaxies, planets and listeners could exist. The image of a quilt can help soften the technical idea. Picture yourself sitting in a quiet room, an old patchwork quilt draped over your lap. Each square tells a story. One has faded flowers, another geometric stripes, another a soft pastel. They are not identical, but together they make something comforting, something whole. Now stretch that quilt beyond imagination, so wide it covers not just your bed, not just your house, not just your world, but reality itself. Each patch is a universe, stitched by the hand of inflation, patterns determined by initial conditions and cosmic symmetry breaking. Somewhere on that quilt is our patch, blue and star-speckled, just right for life. But countless other patches stretch beyond, hidden from our sight. There is a humility in this vision. We often think of our universe as inevitable, as the only possible arrangement. But the cosmic quilt suggests otherwise. Perhaps our universe is just one pattern among many, not privileged but simply fortunate. This is where the concept of fine-tuning often arises, the observation that our universe seems delicately balanced for life. If gravity were a little stronger, stars might collapse too quickly. If weaker, galaxies might never form. If the cosmological constant were slightly larger, the universe would expand too fast for structures to gather. If smaller, it might collapse back into itself before life had a chance to appear. Our square of the quilt, then, feels carefully sewn. And yet in the multiverse picture there may be countless squares, most unsuitable for life, with only a few capable of producing the delicate embroidery we see around us. From another angle, the quilt metaphor reveals not just diversity but connection. Though each square has its own design, all are part of one fabric. Likewise, even if other universes are forever inaccessible, they may still belong to a single overarching reality. They may be stitched by the same inflationary process, governed by the same deeper framework, perhaps string theory or something beyond. To imagine this is to stand before an immense tapestry, stretching in every direction, with our little patch glowing quietly within it. Of course, some scientists are cautious with these images. They remind us that we have no direct evidence for other bubbles, no way to observe the patterns of their squares. The quilt may be only a metaphor useful for thinking, but not yet confirmed by observation. And yet, even as a metaphor, it offers something precious. It reminds us that our universe need not be the only way reality can be. It loosens the grip of inevitability and opens the door to imagination. Everyday life, too, is full of quilts. You may have one folded at the foot of your bed, stitched by a grandmother or bought at a market, made of scraps from many sources. Each patch might have once been part of a shirt, a dress, a curtain. Each holds a memory, and together they hold warmth. Thinking of the cosmos as a quilt is not only a scientific metaphor but also a human one, linking the vast and the intimate. The same sense of patchwork that warms you at night may describe the fabric of all that is. So tonight, as you picture the multiverse, imagine it not only as bubbles rising in an internal bath, but also as squares stitched into an endless quilt. Imagine the patterns we will never see, the colours we will never know, the stories written in the physics of other worlds, and then draw the quilt gently over your shoulders and feel the comfort of knowing that our universe, for all its vastness, is part of something even larger, even richer, even more mysterious. In the next session, we will wander into another speculative picture, one that does not rest on quilts or bubbles, but on the hearts of stars collapsing into darkness. For some physicists have suggested that black holes may be more than graves, they may be wombs where new universes are born. But before we travel there, rest a moment with the quilt across your imagination. Feel the weight of it, the softness, the sense that reality, like fabric, is both continuous and varied. Our square glows here, tonight, while countless others glow unseen. When most of us think of black holes, we imagine them as endings. They are the great cosmic gulfs, the bottomless pits of space where light itself is swallowed, and from which nothing, not even information, seems to escape. The very name carries finality. A hole, an absence, a void without return. Yet some physicists, looking at these dark giants with both dread and curiosity, have asked a softer, stranger question. What if black holes are not only endings, but beginnings? What if, inside those collapses of matter and time, new universes bloom, sealed off from our own yet alive with their own space, their own time, their own stars? The idea seems almost whimsical at first, like a fairy tale inversion where death becomes birth. But it arises naturally from the mathematics of general relativity. A black hole, at least on paper, does not stop at the event horizon. Inside, space-time continues to curve, funneling down to a singularity, a point where densities become infinite, where the known laws of physics break. For decades, this singularity was seen as a sign of incompleteness, a limit of understanding. But some theorists have suggested another possibility. Perhaps the singularity is not an endpoint at all, but a throat leading into a new region of space-time disconnected from ours. In this vision, every black hole might be a kind of seed, and every seed might sprout into a universe. To make this less abstract, think of a garden in autumn. Seeds fall into the soil. To the plant above it may seem like an ending, a return to darkness. Yet underground, hidden from view, something new begins. Roots form, shoots prepare, life gathers itself for another cycle. In the same way, a star collapsing into a black hole may appear from the outside as a death. Yet within, beyond our horizon of knowledge, a new cosmos could be taking shape, budding like a seed in hidden soil. This idea is sometimes called cosmological natural selection. Just as life on Earth adapts through reproduction, universes might reproduce through black holes. A collapsing star creates a black hole. The black hole forms a new universe inside. That universe, in turn, spawns its own stars and black holes, which then bud off still more universes. It is a grand, branching tree of reality, with black holes as the fruit from which new realities grow. Each universe could inherit slightly different physical constants, just as children resemble but do not perfectly match their parents. Over time, universes with laws that favour the production of black holes would become more numerous, since they are better at reproducing. It is an audacious idea, blending cosmology with a whisper of Darwinian evolution. For our purposes tonight, though, we need not wrestle with the technical details. There's enough to rest in the imagery. Picture the night sky filled with stars. Every so often, a star reaches the end of its life. It grows unstable, it collapses, and in that collapse, a black hole forms. To us, it seems tragic. A bright sun disappearing into darkness. But if the theory holds, then in that very moment, a universe is born. Not one we can ever see, for its space is not connected to ours, but one that exists nonetheless, carrying on a hidden legacy. Everyday life is full of similar paradoxes. The caterpillar spins a cocoon, and to the outside world it looks as though the creature has ended. Yet within, transformation takes place, and soon a butterfly emerges. A forest fire consumes trees, and for a time it seems only devastation remains. Yet in the soil, seeds crack open, nourished by ash, and the forest grows again. Endings and beginnings are often the same event, depending on where you stand. So too with black holes. From our side, they are endings. From another perspective, they may be beginnings. What would such daughter universes be like? Here the imagination must step softly, for no observation can guide us. Some may be barren, with laws of physics so unfriendly that nothing complex arises. Others may be vibrant, with galaxies and stars, perhaps even life. They would be sealed from us, unable to communicate across the walls of space-time. Yet their existence would add another patch to the multiverse quilt, another bubble to the eternal bath. The thought that our universe itself might have been born from a black hole in some earlier cosmos is both unsettling and strangely comforting. It suggests that reality is fertile, that new worlds are always budding even as others collapse. It makes the cosmos less like a static machine and more like a living forest, where growth and decay are woven together. Of course, there are skeptics. The mathematics is speculative, the evidence non-existent. Many physicists regard the idea as poetic but unproven, a curiosity rather than a conclusion. And yet science has often begun with such curiosities, with questions that sound too strange to be true. Whether or not black holes truly give birth to new universes, the idea serves a purpose. It reminds us that the boundaries of our imagination need not stop at the edge of observation. It encourages us to see even the darkest places in the cosmos as potential sources of creativity. So tonight, as you think of black holes, do not picture only voids or monsters. Picture seeds, picture cocoons, picture doorways. Picture the possibility that every dark collapse is balanced by a hidden dawn, that every star's death is also a universe's birth. And as you drift towards sleep, let that thought settle. Endings and beginnings are not opposites, but partners. Even the darkest depths may carry the spark of creation. When you flip a coin, you expect one of two outcomes. It lands heads, or it lands tails, and reality seems to choose one path while discarding the other. You pocket the coin, move on with your day, and the possibility that didn't happen dissolves like mist in the morning sun. But in 1957, a young physicist named Hugh Everett dared to ask, what if reality never discards possibilities? What if, instead of choosing, the universe simply allows both outcomes, each unfolding in its own branch of existence? In one universe, the coin lands heads. In another, tails. And you somehow continue in both. At the time, Everett was just a graduate student at Princeton. He proposed this interpretation of quantum mechanics not as a bedtime story, but as a serious solution to one of physics' most perplexing puzzles, the problem of measurement. In quantum theory, particles such as electrons and photons can exist in multiple states at once, a strange condition called superposition. An electron can be here and there simultaneously. A photon can travel along two paths at once. But when we measure them, we see only one outcome. Why? The dominant answer for decades was that measurement itself collapses the superposition, forcing the universe to choose. But Everett suggested something more radical. Perhaps there is no collapse at all. Perhaps all outcomes occur, each in its own separate world, forever branching away from the others. To picture this, you might imagine a tree. At the base is the trunk, the shared past. As you move upward, the trunk divides into branches. Each branch is a possible future, and as time passes, the branches split further and further, until the tree becomes a vast, tangled canopy. According to Everett, reality is that tree. Every quantum event, every coin flip, every photon, every roll of dice splits the universe into branches. You live along one, but countless versions of you continue along the others. This sounds absurd at first, almost laughably extravagant. Why invent countless universes just to explain the behaviour of a particle? And yet, Everett's proposal has a strange elegance. It removes the need for a mysterious collapse. The mathematics of quantum theory runs smoothly, without exceptions. The branching is not an add-on, but a natural consequence of taking the equation seriously. If you accept the math, the many worlds come with it, like shadows you cannot avoid. Of course, everyday life does not feel this way. When you pour milk into your coffee, you see it swirl into one cup, not split into two. When you choose to turn left at a corner, you walk down one street, not both. The many worlds interpretation suggests that behind the scenes reality is not so decisive. You walk down both streets, but in separate branches, with separate versions of you. One version might bump into an old friend, another might find a new cafe. Both stories are real, though each version of you experiences only one. The strangeness of this idea is softened by metaphors. Imagine a book whose plot splits at each chapter. In one version, the hero turns back. In another, they press forward. Both versions are written, both exist, but as a reader you follow only one path at a time. The universe, Everett suggested, is like that book, but all the stories are happening simultaneously, with no single narrative privileged above the others. Some physicists, such as Bryce DeWitt, championed Everett's idea, seeing it as the only interpretation that takes quantum mechanics literally without adding hidden rules. Others dismissed it as untestable, unscientific, or simply too bizarre. For decades it lingered on the margins, more philosophy than physics. Yet over time it gained a following, not only because of its conceptual clarity, but also because it resonates with the way quantum computers seem to operate. In a quantum computer, calculations unfold as if many possibilities are explored at once, before the final answer emerges. David Deutsch, one of the pioneers of quantum computing, argued that this is evidence for the reality of many worlds, that the computer's power comes from harnessing parallel universes. To those who find Everett's vision compelling, the scale of branching is staggering. Every particle interaction, every quantum fluctuation, every uncertain event multiplies the tree of reality. The number of branches grows unimaginably vast, so much so that our universe is but one thread among countless. In this picture, reality is not a single story, but an infinite library. Every book written, every page turned, every path followed. And yet, for all its radical nature, the many worlds interpretation can be strangely comforting. It suggests that nothing is ever truly lost, that every possibility has its place. When you think of the roads not taken, the choices not made, the lives unlived, Everett's theory whispers that they are not gone. They are simply happening elsewhere, with other versions of you walking them. It is not proof, not something you can confirm, but as an image, it is haunting and gentle. Reality, as a forest of endless paths, everyone real. Of course, not everyone agrees. Some say the many worlds interpretation is too extravagant, that it multiplies realities without evidence. Others point out that it is difficult, perhaps impossible to test. But tonight, those debates can rest. For now, it is enough to imagine Everett as a young man scribbling equations, daring to propose that our universe is not alone, but forever branching, every moment spawning new worlds. So, as you lie here listening, picture the coin spinning in the air, picture it shimmering between heads and tails, both possibilities suspended. When it lands, perhaps reality does not choose, perhaps it splits. In one universe you smile at heads, in another you sigh at tails, and in countless others, other coins spin, other choices unfold, other stories are written. The tree of reality grows on, vast, branching and beautiful, and you are part of its living canopy. If Everett's proposal planted the seed of the many worlds interpretation, then the branching tree of possibilities is the forest it has grown into. To picture it, let your mind wander into a woodland at dusk. The light is soft, the air cool, and before you, a path winds ahead. Soon it forks into two trails. You could walk left, or you could walk right. In ordinary life, you choose one and abandon the other. But in the forest of quantum mechanics, both paths are taken, each by a version of you, each unfolding into its own story. As you walk deeper, the path splits again and again, until the forest becomes an endless network of choices, each one real, each one alive. Physicists like Max Tegmark have taken this picture seriously, speaking of reality as a branching tree of universes. Each quantum event is like a fork in the trail, multiplying worlds. The scale is overwhelming. In the time it takes for you to blink, trillions of quantum events have branched off, spawning universes beyond counting. Every atom in your body is constantly interacting, splitting into possibilities. The forest grows not in centuries or years, but in every heartbeat, every moment, every fraction of a second. To make this less abstract, think of a bottle of sparkling water. You open it, and bubbles fizz upward, countless tiny spheres rising and splitting as they go. Each bubble is a possibility, a branch of reality. You can't track them all, they multiply too quickly, but you can feel the effervescence, the sense that beneath the surface, more is always happening. That is the many worlds forest in miniature, a fizz of universes, invisible but implied by the mathematics of quantum theory. The philosopher David Deutsch has argued that quantum computers provide a kind of practical proof of this branching. In a quantum computer, calculations are not performed one at a time, as in a classical machine, but in parallel, as if many possible computations are happening simultaneously. When the result appears, it is as though the machine has borrowed strength from countless parallel worlds, each contributing to the answer. Deutsch calls this the multiverse at work. Parallel universes cooperating in a sense to allow computation that would otherwise be impossible. Not everyone agrees with this interpretation, but the image is striking. Imagine a forest where every path leads to a different group of travellers, yet somehow they all sing the same chorus. Each branch of the song strengthens the whole, even though no one singer hears the others. If this forest of choices exists, then it reshapes how we think about our own decisions. We are used to thinking of a life as a line, each choice closing off possibilities. But in many worlds, no possibility is ever lost. Every path is taken, every road explored. When you decide to move to a new city, in one branch you go, in another you stay. When you call a friend, in one branch they answer, in another they miss the call. Each choice is not a narrowing, but a multiplication. It is both an unsettling and a liberating idea. It is unsettling because it suggests that you're not unique. There are countless versions of you, walking countless paths, making countless choices. Somewhere, another you is reading a different book, listening to a different song, living a different life. But it is also liberating because it suggests that every possibility has a home. Nothing is wasted. Every path exists. When you wonder what might have been, the answer is simple. It is. Somewhere, in some branch, it is. Everyday metaphors can soften this strangeness. Think of a great library filled with books. Each book tells a slightly different story, one where the hero turns back, one where they press forward, one where they stumble into an unexpected adventure. In our everyday life, we read only one book. But in the many worlds picture, every book is written, every story told, every ending reached. The library is endless, and every shelf is full. Or imagine a great river flowing to the sea. At first it is one stream, strong and unified. Then it divides into branches, splitting around islands, diverging into deltas. Each branch is still the river, still water flowing, but each finds its own course. Eventually, all reach the ocean, but the paths are many. So too with reality. A river splitting into countless channels, each carrying a version of the events. Physicists sometimes call this branching decoherence. It is not that universes actively split with a thunderclap. Rather, quantum possibilities lose their ability to interfere with one another like singers, drifting apart until their voices can no longer blend. What was once one song becomes many, each carried on its own breeze. From our perspective, the result is a single outcome. From the perspective of the theory, all outcomes exist, each drifting away into its own world. What is striking is how ordinary this can feel once translated into images. The forest of choices is not a chaotic mess, but a quiet, orderly unfolding, each path as real as the next. The bubbles of sparkling water are not frightening but refreshing, a sign that possibility is always alive. The library of stories is not overwhelming but comforting, reminding us that no story is lost. And yet, for all its gentleness, the forest of choices raises profound questions. If every possibility is realized, what becomes of meaning? Does it matter which choices we make if other versions of us make the opposite ones? Some philosophers argue that it does not diminish meaning at all. You're still you, walking your path, living your story. The existence of other branches does not rob your branch of value. It simply multiplies the richness of reality, just as the existence of other books does not lessen the joy of the one you read. The existence of other universes does not lessen the significance of the one you inhabit. So, as you rest tonight, picture the forest. Picture paths splitting endlessly, fading into the mist. Somewhere, another version of you has turned left, while you turned right. Somewhere, another coin spun and landed differently. Somewhere, another song plays, another story unfolds. The forest is infinite, but you are here, on this path, in this moment, and that is enough. By now, the picture of many worlds may already feel immense, a forest of choices, a library of stories, a sparkling fizz of possibilities. But if we pause and consider the scale of this branching, the imagination begins to stagger. For the branching is not rare, not occasional, it is constant, happening everywhere, every moment, with every particle. What seems to us like a single smooth reality is, under Everett's interpretation, a vast explosion of alternatives, a cosmic firework that never ends. To bring this down to earth, imagine opening a bottle of soda. Bubbles surge upward, far too many to count. You may try to follow one or two, but they multiply faster than your eyes can track. The many worlds interpretation suggests that reality is like this, an effervescence of universes bubbling into being with every quantum event. When you blink, when you breathe, when light scatters off the walls of your room, branches multiply, and each is as real as the one you feel yourself inhabiting. The numbers involved are beyond comprehension. Physicist Max Tegmark has estimated that the branching is so vast that in the space of a moment every possible configuration of matter you can imagine already exists somewhere in the multiverse. The scale is not like a forest of trees, but like a rainforest covering an entire planet. Every leaf, every insect, every drop of water a possibility realized. You and I, listening here tonight, are part of one configuration, but countless other configurations exist alongside us, in universes that differ by a hair's breadth, or by an entire history. This can be dizzying, so it helps to soften the image. Picture yourself standing before a mirror. You see your reflection, familiar and singular. Now imagine another mirror placed at an angle and another, until reflections multiply, stretching away into infinity. Each image is slightly different. A tilt of the head, a flicker of expression, a shadow falling just so. They are all versions of you, each real within the glass. The many worlds picture is like standing in such a hall of mirrors, except that the reflections are not illusions. They are universes, each carrying on with its own light, its own time. In daily life, we rarely feel this multiplicity. When you sit at breakfast and choose between tea and coffee, you only taste one. Yet, in Everett's strange proposal, both choices are taken, both universes continue, and both versions of you sip quietly, never aware of each other. The branching is seamless, hidden, like the splitting of a stream underground, invisible on the surface but flowing into countless channels below. Some find this picture troubling. If every possibility exists, does that mean every tragedy is realized? Does it mean that every mistake, every misstep, every sorrow also happens in some branch? In one sense, yes. But the opposite is true as well. Every joy, every triumph, every possibility of beauty also happens. The scale of branching contains both shadows and light. Every melody ever written, and every silence between notes. Seen this way, the multiverse is not a burden, but a fullness, a reminder that reality is abundant beyond our imagining. To appreciate this abundance, think of a night sky filled with stars. You know that what you see is only a fraction of what exists. For every star you can name, there are countless more hidden beyond the limits of your vision. The many worlds interpretation invites you to think of possibilities the same way. For every path you walk, there are countless others hidden from your sight, unfolding elsewhere, real but unreachable. The scale is not frightening when softened into starlight. It is simply vast, like the cosmos itself. David Deutsch has argued that this branching scale is not mere philosophy, but may be reflected in the power of quantum computation. A quantum computer, in his view, does not merely juggle possibilities within one universe. It draws on the parallelism of many worlds, performing calculations across them before bringing the results back into our branch. Not everyone agrees with this interpretation, but the imagery is compelling. A machine whispering across universes, borrowing a little strength from each. It is another way of feeling the scale, another way of recognizing that what we call our reality may be only a thin slice of a far richer whole. For most of us, though, the branching scale is best approached as a metaphor. It is not something we can measure directly or test easily, but it is something we can imagine. Picture a great orchard stretching farther than the eye can see. Every tree is laden with fruit. Each fruit is a universe, each branch a history. You wander among them, tasting one, while others hang heavy, untouched. You will never eat them all, never walk the whole orchard, but it is there, abundant, waiting. That is what the many worlds picture feels like at scale, an orchard of infinities, every possibility ripening somewhere, every story finding its place. As you drift with this thought, it is worth remembering that whether or not the many worlds interpretation is true, the imagery itself can be soothing. It tells us that our choices, however small, are not isolated. They belong to a grander tapestry of possibility. The life you live is one branch among countless, but it is still yours, no less real, no less valuable for being one among many. Like a single note in a symphony, it is part of something larger, yet it sings in its own right. So tonight, as you rest, let your thoughts expand with the scale of branching. Picture bubbles rising in endless streams, mirrors multiplying into infinity, orchards heavy with fruit, skies filled with stars. Picture reality not as a single line, but as a symphony of paths, every note played, every silence held. And in that abundance, find calm. For though the multiverse may be vast beyond imagining, you are here, in this branch, in this moment, listening, breathing, and that is enough. When physicists speak of the multiverse, they do not always mean bubbles or branches. Sometimes they speak of something even stranger, the possibility that universes differ not only in arrangement, not only in histories, but in their very laws. Imagine walking into a vast garden where every flower blooms with its own colour, its own scent, its own secret chemistry. Each flower is familiar, you recognise it as a flower, but each follows its own design. That, in essence, is how the idea of the string theory landscape enters the multiverse conversation. A garden of laws, each universe blossoming with different rules. String theory, in its simplest description, suggests that the fundamental building blocks of reality are not particles, but tiny vibrating strings of energy. The way a string vibrates determines whether it appears as an electron, a photon, or some other entity. But for string theory to work, it requires more than the 3 dimensions of space we know. It requires additional dimensions, curled up so tightly that we cannot see them, like threads woven into fabric too fine for the eye. These hidden dimensions can fold in many ways, and each folding gives rise to a different set of physical laws. The result is not one universe, but an immense landscape, so immense that estimates suggest there could be 10 to the power of 500 possible arrangements, each a potential cosmos with its own constants, its own physics. The number is absurdly large, too large to grasp. But we do not need to hold it in numbers. We can hold it in images. Picture a library with shelves stretching forever, each book containing a different version of reality. Some books are slim, some are thick, some are written in languages we cannot understand, but they are all books, all stories, all real within the library. The string theory landscape is such a library. Universes stacked upon universes, each page written by the folding of dimensions. Or imagine, if you prefer, a patchwork of gardens. In one, roses grow with petals of gold. In another, sunflowers glow blue in moonlight. In another, vines curl with silver leaves. The gardener is not deliberate, not choosing each design. Instead, the seeds sprout according to the soil, the sunlight, the hidden chemistry of the ground. String theory suggests that reality may be like this. The hidden dimensions curl into shapes, and those shapes decide the rules of the universe that emerges. Some universes bloom with balance where stars and atoms can exist. Others may bloom with chaos, unstable, barren, collapsing before they can form structure. Our universe, then, is simply one flower in this endless garden, one book on the infinite shelf. It is tempting to ask why we live in this one and not another. The answer, some suggest, is that we live here because here is one of the rare places where life is possible. Most flowers of the garden may be sterile. Most books may tell stories too short to allow readers. But in this blossom, this text, conditions allow complexity, chemistry, and consciousness. We're not special because the garden was grown for us. We're here because only certain blossoms can support beings like us to notice them. This way of thinking is sometimes called the anthropic principle. It is controversial because it seems to invert science's usual ambition. Instead of predicting why constants have their values, it suggests that constants vary across the multiverse, and we simply find ourselves in a universe compatible with life. But set aside the debate for a moment and simply rest in the imagery. A garden of universes stretching farther than imagination, each blossom unique, most unseen, most uninhabited. And here you are, under the petals of one flower, noticing its fragrance, wondering what lies beyond. If you have ever walked through a botanical garden, you know the sensation. One path leads to orchids, delicate and intricate. Another leads to towering palms, another to dessert succulents, fat with hidden water. All are plants, all part of life's great tree, but each adapted to its own corner of the earth. The string theory landscape is a cosmic extension of that same variety. Instead of different leaves or roots, it offers different values for fundamental, constants, different recipes for reality. Some universes are lush jungles, others are barren deserts. Some glow bright, others never ignite. This imagery does not make the mathematics less daunting, but it makes the idea gentler to carry. Instead of drowning in exponents and vast numbers, we can sit in the garden, watching blossoms sway, feeling their differences, knowing that ours is only one among many. Perhaps there are universes where gravity is stronger, pulling matter into dense clusters. Perhaps others where it is weaker, leaving galaxies too diffuse to form. Perhaps some where chemistry never takes hold, where atoms themselves are unstable. And yet, in this one, balance holds, and we are here. At night, when you walk through your own garden or even a small park, you may feel something similar. The fragrance of a rose is not lessened by knowing that a daisy or a lily blooms elsewhere. The sight of one tree is not diminished by the existence of another. In the same way, the possibility of countless universes does not diminish ours. It adds depth, variety, and wonder. So tonight as you rest, imagine yourself wandering in a garden that stretches beyond sight. Flowers of every hue line the path. Some wilt quickly, some endure. Some dazzle with colours unseen on earth. Others remain pale and quiet. Somewhere in that garden is the flower we call our universe, rooted in just the right soil, watered by just the right balance of laws, blooming long enough for us to be here, thinking, listening, drifting. The rest of the garden may be unreachable, but it is no less real for being unseen. And when you close your eyes, perhaps you will carry that garden with you into dreams, a landscape of universes blooming endlessly, each a possibility, each a story, each a reminder that reality is always more abundant than we can imagine. If the string theory landscape is a garden of laws, then the next question is why our flower blooms the way it does. Why is our universe stitched together with precisely these values, these numbers, these constants, and not others? The question is not trivial. Change the constants even slightly and reality unravels. Gravity a little stronger, and stars burn out before they can nurture life. Gravity a little weaker, and galaxies never gather. The cosmological constant, the tiny pressure that accelerates expansion, could easily have been too large, tearing the universe apart before matter could cluster, or too small, causing everything to collapse. Yet here we are, in a cosmos tuned just so. To soften this puzzle, think of an old-fashioned radio. You turn the dial and static hisses, an ocean of noise, but at certain narrow frequencies the static clears and a melody emerges. You adjust the knob gently until the signal sharpens. Too far left and you lose the music, too far right and the noise drowns it again. The station is a narrow oasis of clarity in a desert of interference. Our universe, in this metaphor, is one of those rare stations. Its laws, its constants, its balances are tuned just enough to allow atoms, stars, planets, and listeners. Too far off frequency, and there would be only silence. The image of a dial helps us understand the delicacy. There is not an infinite range of universes that can sustain complexity. There is a narrow band, a slim slice of possibility, and we happen to live within it. Some call this coincidence, some call it providence, some call it the anthropic principle. We observe these constants because only in such a universe could observers exist to wonder about them. Whether you see this as profound or circular, it is difficult to deny that the constants are tuned in a way that feels uncanny. This tuning is not confined to gravity or cosmic expansion. Consider the strength of the electromagnetic force which governs chemistry. If it were slightly different, atoms would not bond the way they do. Carbon, the backbone of life, might not form stable chains. DNA would never arise, proteins would never fold, and life would remain impossible. Or consider the masses of protons and neutrons. Change their ratio just a little, and the universe would be flooded with hydrogen but no heavier elements, or with unstable particles that decay too quickly to build complexity. The recipe of our universe is not random flour and sugar spilled on a table. It is a recipe with exact proportions, baked just long enough, at just the right temperature to rise. To carry the metaphor further, picture yourself in a kitchen. You measure flour, water, yeast, salt. Too much yeast, and the dough balloons collapsing into sour air. Too little, and the loaf sits heavy, flat, lifeless. The right balance yields bread that is light and strong, nourishing and fragrant. Our universe is like that loaf. Its ingredients are constants, measured not by spoons but by the curling of dimensions and the structure of physics. Out of countless possible recipes, this one baked into the world we know. And here is where the multiverse enters again. If there are countless universes, each with its own recipe, then most are doomed loaves, collapsed or unrisen. But some, like ours, are baked just right. We should not be surprised then that we find ourselves here, any more than a loaf should be surprised to be edible. We're here because this universe allows it. That does not solve the mystery entirely, but it reframes it. Instead of asking why this loaf turned out perfectly, we recognise that countless others exist unseen, and we live in one of the few that rose. Steven Weinberg once used this reasoning to predict the existence of a small, positive cosmological constant. He argued that if there were a multiverse of universes with different values, then observers would only exist in those where the constant was small enough to allow galaxies to form. His prediction was later confirmed when astronomers discovered that our universe's expansion is indeed accelerating, driven by just such a constant. This does not prove the multiverse, but it shows that anthropic reasoning can be surprisingly powerful, a whisper from the static that turns out to be music after all. Some physicists resist this way of thinking. They prefer explanations that derive the constants from deeper laws, not from anthropic reasoning. They worry that invoking the multiverse risks ending inquiry, as though we simply shrug and say, "We are here because we can be." And yet, others argue that the multiverse opens inquiry further. It suggests that reality is vast, that there are many dials, many recipes, many stations, and our task is to understand how they are arranged. For us tonight, there is no need to settle the debate. It is enough to feel the delicacy of the tuning, the narrowness of the band that carries our melody. Imagine again the radio dial, the knob turning, the static roaring on either side. Somewhere between the noise a song plays, fragile but clear. That song is our universe. You're listening to it now, every moment, every heartbeat, every breath. So as you lie back and let your thoughts drift, picture the cosmos as a radio, its dial turning across infinite frequencies. Most yield only static, barren universes without form or life. But on one narrow station, the signal comes through, the music plays, stars shine, planets spin, oceans glimmer, and you, improbably, impossibly, are here, tuned into this fragile frequency of existence. When you sit quietly and look around your room, everything seems solid, inevitable. The walls, the floor, the familiar objects on your table. It feels as though the universe could not have been any different. But beneath that comforting sense of permanence lies a delicate puzzle. The universe is balanced on a set of numbers so precise that if even one were altered, the room you are in, the stars above you, the atoms that make up your body would not exist. These numbers are called the constants of nature, and they are the silent scaffolding of everything. Consider first the strength of gravity. It is weaker than any of the other fundamental forces, weaker by a staggering margin. If it were much stronger, stars would burn out quickly, collapsing before planets could form, snuffing out the possibility of life before it began. If it were much weaker, matter would drift aimlessly, galaxies never condensing, stars never igniting. Gravity is not set too high, not set too low, but balanced in the middle, a cosmic Goldilocks. Now think of the electromagnetic force, the invisible tether that binds electrons to protons. Its strength determines the structure of atoms and therefore chemistry itself. If it were stronger, electrons would cling too tightly. Molecules would be rigid, unresponsive, incapable of the delicate dances that life requires. If it were weaker, atoms would barely hold together, chemistry dissolving into chaos. Again, the value is tuned, not too strong, not too weak, but just enough to allow carbon, oxygen, and all the molecular diversity that paints our world. The puzzle continues with the masses of the particles themselves. The neutron, just slightly heavier than the proton, allows hydrogen to dominate the universe, while also permitting the fusion that creates heavier elements in stars. If neutrons were a touch lighter, hydrogen would vanish. If they were heavier still, stars could not forge the elements we need. A sliver of difference and the story of life is erased. Perhaps the most famous constant of all is the cosmological constant, the small positive value that accelerates the expansion of the universe. Too large, and galaxies would never form, space rushing apart too quickly for matter to gather. Too small, and the cosmos would collapse back on itself, never giving life a chance. In our universe, the cosmological constant is neither extreme. It is tiny, so tiny compared to theoretical expectations that physicists scratch their heads, but precisely what is needed for the cosmos we see. To hold these puzzles together, think of a recipe written with astonishing precision. A pinch too much salt and the dish is inedible. Too little and it is bland. Too long in the oven and it burns. Too short and it remains raw. Our universe is a recipe written not with pinches and minutes, but with constants and forces, each tuned as if by an unseen chef. The result is a cosmos that allows stars to shine, planets to form, and you to sit quietly, listening to this story. This fine-tuning is what makes the multiverse such an appealing idea to many scientists. If there are countless universes, each with different constants, then it is not surprising that we find ourselves in one that works. It is like a lottery. Most tickets are worthless, but in a sufficiently large lottery, some must win. We live in one of the winning tickets, not because it was destined, but because only here could life arise to notice it. But not everyone is satisfied with this reasoning. Some physicists prefer to believe that the constants must be derived from a deeper law, a hidden principle that dictates their values. To them, saying we are here because the constants allow us feels incomplete, like explaining a clock by saying it ticks because it does. They seek a mechanism, a reason, a unifying truth. Whether such a principle exists remains an open question. For tonight, though, we can rest with the puzzle itself without rushing to answers. Imagine you are holding a violin. The strings must be tuned precisely. Tighten too much, and the note is sharp and harsh. Loosen too much, and it is flat and dull. But tuned just so. The strings sing, and music fills the room. The constants of nature are like those strings. Somehow the universe is tuned, not harsh, not flat, but resonant, producing the melody of existence. As you lie back, think of this tuning not as an argument to solve, but as a wonder to behold. Every star you have ever seen, every breath you have ever taken, every thought you have ever had, depends on the balance of these constants, a balance so delicate, so exact, that it feels less like a machine and more like a symphony. You are part of that symphony. You're listening to it now in the quiet of the night, each constant holding its note, each law of physics keeping time, the music unfolding across billions of years. And if the multiverse exists, then there are countless symphonies, countless recipes, countless dials turned to different values. Most are discordant, silent, barren. But here, in this universe, the notes ring true. The bread has risen, the station plays clearly. It may be chance, it may be necessity. It may be something we do not yet understand. But whatever the reason, the fact remains. You are here, the constants hold, and the universe sings. Sometimes, in science, a quiet prediction is made long before the evidence arrives, and when the universe later confirms it, the effect feels almost like a whisper across time. One of the most famous examples in the context of the multiverse comes from the physicist Steven Weinberg, who in the late 1980s dared to use anthropic reasoning to predict something about the cosmos. His prediction was not about planets or galaxies, but about the cosmological constant, the faint pressure that drives the expansion of space itself. Weinberg asked a deceptively simple question. If there are many possible universes, each with a different value for the cosmological constant, in which ones could life exist? Too large, and matter would never condense into galaxies. The universe would rush apart too quickly, scattering atoms into a cold, diffuse fog. Too small or negative, and the cosmos would collapse back on itself before structures had time to grow. Only in a narrow range would galaxies, stars and planets be possible, and only in those galaxies with their stable chemistry and long-lived suns could observers arise to wonder. Using this reasoning, Weinberg argued that we should not expect the cosmological constant to be exactly zero. as many physicists at the time hoped, but to be small, positive, and just large enough to allow galaxies to form. His argument was not mathematical in the usual sense, but statistical and anthropic. Given a multiverse of possibilities, we will inevitably find ourselves in one of the rare universes that allow life. He estimated the likely value and published his thoughts. At the time, many were skeptical. The cosmological constant was mysterious, but the idea of using anthropic reasoning to predict its value felt like giving up on deeper explanations. It seemed to some more like philosophy than physics, more like an admission of ignorance than a triumph of knowledge. And yet, a decade later, in 1998, astronomers studying distant supernovae discovered that the expansion of the universe is indeed accelerating. The driving force, a small, positive cosmological constant astonishingly close to what Weinberg had anticipated. The discovery stunned the scientific community. Dark energy, as it is often called, became one of the central mysteries of modern cosmology. And Weinberg's prediction, once dismissed as speculative, gained a kind of retrospective glow. He had not proven the multiverse, of course, but he had shown that reasoning about many possible universes and about the narrow slice that permits life could lead to real, testable expectations. It was as though he had leaned close to the cosmo and listened carefully enough to hear its faint tune, then whispered it to the world before the instruments confirmed it. To make this gentler, picture yourself sitting in a quiet cafe. A radio hums softly in the background, playing static more than music. You turn the dial slowly, not knowing what you'll find. Suddenly a faint melody emerges. You recognize it, though it is quiet, almost drowned in noise. You smile because you had guessed it would be there, and now you hear it. That was Weinberg's whisper, predicting the faint music of cosmic acceleration before anyone else could tune it clearly. For many, this strengthened the case for thinking in multiverse terms. If the constants can vary, and if we can reason about the values that allow life, then perhaps anthropic thinking is not just hand-waving, but a useful tool. Others remained uneasy, worried that such reasoning risks replacing deeper explanations with mere survivorship logic. But even the skeptics admitted that Weinberg's success was remarkable, a case where the multiverse framework seemed to pay intellectual dividends. From our perspective tonight, we can let the debate soften and simply appreciate the strangeness. Imagine again the vast radio dial of reality. Countless universes are static, barren, uninhabitable. Only a few carry melody. Weinberg's insight was to recognize that we should expect to find ourselves at one of those rare stations, not because the dial was built for us, but because only there can listeners exist. And when astronomers later tuned their telescopes, they heard the faint song of acceleration exactly where he had said it would be. There is something poetic about this. The universe is not always generous with answers. It hides its workings in numbers too large to fathom, in particles too small to see, in distances too vast to cross. But sometimes it rewards a quiet question with a quiet reply. Weinberg's whisper reminds us that even in the strangest realms of physics, where speculation brushes the edges of philosophy, patience and imagination can sometimes meet reality. As you lie back tonight, let the story settle like soft music. Think of the cosmos not as a machine grinding forward, but as a song carried on a fragile frequency. Weinberg guessed that the music must be there, faint but steady. And later, with careful listening, we heard it. That is the beauty of science at its best. Not certainty, not final answers, but whispers in the noise, melodies emerging from static, a reminder that the universe, however vast, sometimes lets us in on its secrets. When Max Tegmark, a physicist with a taste for daring ideas, tried to classify the multiverse, he began with the simplest level. He did not start with bubbles of eternal inflation, or with quantum branches, or with string theory's labyrinth of laws. He He started with something that feels almost obvious once you see it. The possibility that what lies beyond our cosmic horizon is simply more of the same. He called this level 1 of the multiverse, and in many ways it is the least exotic. It does not demand new physics. It does not rewrite the laws of nature. It only asks us to accept what the equations already suggest, that the universe is larger than the part we can see. Imagine standing on a wide plain covered in morning mist. Around you stretches a circle of grass and trees, fading at the edge into haze. You know, even without seeing that the plain continues. The fog does not mark its end. You trust continuity, because every step you take confirms it. The cosmic horizon is that fog. We can see only as far as light has travelled since the Big Bang, about 46 billion light years in every direction. Beyond that, our sight fails. But the equations of cosmology, the smoothness of the cosmic microwave background, the uniformity of galaxies, all suggest that the pattern continues beyond the mist. The plane does not stop where you stop seeing it. The universe does not stop where we stop seeing it. What makes this level 1 multiverse fascinating is its sheer size. If space is truly infinite, then every arrangement of matter, every possible configuration, must eventually occur. Somewhere far beyond our horizon, another region of space holds galaxies arranged almost exactly like ours. Travel still farther, and there may be another Earth, another you, listening to another version of this very story. In an infinite plane, repetition is not just possible, it is inevitable. This can be difficult to grasp, so let us soften it with an image. Picture a deck of playing cards. Shuffle it thoroughly. You might draw a hand of 5 cards that seems unique. But if you shuffle long enough, repeating the process countless times, eventually the same hand appears again. The odds are low, but in infinity the improbable becomes certain. The level 1 multiverse is like that. Shuffle the stars and galaxies across infinite space, and eventually the same patterns recur. Somewhere, perhaps unimaginably far, the sky looks identical to ours, down to the last constellation. Somewhere, another you is lying awake, wondering about horizons. Of course, we can never reach those regions. The expansion of the universe ensures that they recede faster than light can carry us. They remain beyond our contact forever, but their existence does not depend on our reaching them, any more than the existence of distant lands depends on ancient sailors having the ships to cross oceans. They're implied by the mathematics suggested by the uniformity we observe within our patch. If the universe is infinite, then the multiverse begins at our horizon. Some may shrug and say this is not really a multiverse at all, only a larger universe. That may be true in terminology, but from the perspective of lived experience, it amounts to the same. Regions forever beyond reach, forever sealed off from us, are as good as other universes. We cannot see them, cannot touch them, cannot exchange light or messages. We can only imagine them, just as you imagine the unseen planes beyond the fog. There is something oddly comforting about this. We often feel small in the cosmos, fragile under the vault of stars. But if infinite space repeats its patterns, then we are part of something both endless and familiar. Our lives are unique here, but mirrored elsewhere, not diminished but multiplied. In one sense it makes us less singular. In another it makes us part of a grander whole, stitched into the infinite plane. Everyday life offers parallels. Consider a patchwork quilt again. Lay it across your bed and you see squares repeating, patterns recurring. A floral print here, a stripe there, the same motif appearing again and again. If the quilt were infinite, those patterns would repeat endlessly. You might recognise your favourite square in one place and then see it again far away. Another version, just the same. That is level 1 multiverse. A quilt so vast that every patch you can imagine is sewn somewhere, repeating forever. Or think of a great library with endless shelves. Books are filled with stories, And though the combinations of words are vast, they are not infinite. Given enough shelves, eventually one book will match another exactly. You may wander for lifetimes without finding it, but the certainty remains: repetition lies hidden in infinity. The stars, the galaxies, the atoms themselves may follow the same rule. Somewhere on the shelves of space, your story is written more than once. For many scientists, this level 1 idea is the least controversial. It follows from inflation and from the geometry of space as we know it. It does not require untested interpretations of quantum theory or speculative dimensions. It only requires us to accept that the universe might extend beyond what we can see. And yet, even this modest step is staggering. Infinity is not a concept we can easily hold. It slips through the fingers of thought. But it is enough sometimes to picture the foggy plain, the repeating quilt, the endless shelves, and to know that beyond our horizon, more waits. So as you rest tonight, let your thoughts drift outward, past the Milky Way, past the distant galaxies, past the faint glow of the cosmic microwave background. Beyond that glow lies fog, not because nothing is there, but because light has not yet reached us. Beyond that fog lies more of the same stars and galaxies, atoms and possibilities. And in that vastness, repetition waits, familiar shapes hidden in infinity, stories written again. Level 1 is only the first step into Tegmark's multiverse, but it already stretches farther than the heart can follow. And yet, in imagining it, we feel both smaller and greater, a single square in the quilt and part of the quilt entire. If level 1 of Tegmark's multiverse is simply the extension of space beyond our horizon, then level 2 takes us a step further into strangeness. Here, the universe does not merely stretch, it sprouts. Level 2 is built from the picture of eternal inflation, where space itself continues to expand in patches, bubbling into separate regions that become universes in their own right. If level 1 was the infinite plane disappearing into fog, then level 2 is a pot that never stops boiling, each bubble a cosmos sealed off from the others. In the early universe, inflation expanded space at an extraordinary rate, smoothing out irregularities and setting the stage for galaxies to form. But inflation, in some versions of the theory, does not end everywhere at once. Instead, it fizzles out in pockets, while in other regions it continues, pushing outward, faster and faster. Each pocket where inflation ends becomes a bubble universe, and inside that bubble, physics slows down enough to allow matter, stars, and life. Outside, inflation continues, stretching new bubbles into being. Imagine watching a loaf of bread rise in the oven. Within the dough, tiny pockets of air expand, each one swelling into its own bubble. The bread is one whole, but each bubble has its own boundaries, its own interior. Now replace dough with space, replace air with universes, and the oven with the mathematics of inflation. The image may be imperfect, but it carries the essence, the cosmos as a rising loaf, forever filled with bubbles of reality. What makes level 2 more profound than level 1 is that each bubble may not simply be another region of the same universe. Each one may be stitched with different values for the constants of nature, even different numbers of dimensions. In one bubble, gravity might be slightly stronger, in another, weaker. In one, chemistry as we know it might be impossible, while in another, it might flourish in unfamiliar ways. This is not just repetition across infinity, but variation. It is as if every bubble is a separate recipe, a separate tune on the cosmic radio. To soften this idea, think of an enormous quilt, where not only do patterns repeat, but each square is made with different cloth, dyed in different colours. One square might be soft flannel, another rough burlap, another shining silk. They're all part of the same quilt, but each has its own character. In the level 2 multiverse, universes are not merely repetitions of ours at great distance. They're genuinely distinct, stitched with their own physics, their own textures. Scientists sometimes call this the landscape of possibilities. Inflation acts as the gardener, scattering seeds across an endless field, each seed sprouting into a bubble. Some bloom into universes like ours, capable of sustaining galaxies and life. Others collapse or remain barren. The multiverse in this view is not only vast but diverse, a cosmic archipelago where each island has its own ecosystem. It is here that the anthropic principle enters again. In a level 2 multiverse, most universes are uninhabitable. Their constants are tuned wrongly, their laws too harsh. We live in this bubble not because it is the only one, but because it is one of the rare ones where life is possible. It is like walking into an orchard where most of the fruit is bitter, but here and there you find a sweet apple. You should not be surprised to be eating a sweet apple, because only sweet apples can be eaten. Likewise, we should not be surprised to be in this bubble, because only in such bubbles can listeners exist to wonder about them. Of course, we can never travel to these other bubbles. The space between them is still inflating, expanding faster than light, forever keeping them apart. They are unreachable, sealed off by the very physics that birthed them. But in the mind's eye, we can wander there. Imagine a vast bath filled with shimmering soap bubbles. Each reflects its own rainbow, each fragile, each separate. If you peer closely, you see your reflection in one, but countless others glisten beyond. That is level 2 of the multiverse. Not one bubble, but many, each alive with its own possibilities. Some scientists are cautious with this picture. They remind us that it is speculative, that we lack direct evidence. Others embrace it, seeing it as the natural consequence of inflation. Whether proven or not, the image has a poetic resonance. It suggests that creation is not singular, not confined to one moment 13.8 billion years ago, but ongoing, a fountain forever spraying bubbles of reality into being. So tonight, as you let your mind drift, imagine yourself floating in that bubble bath of universes. Imagine each bubble glowing faintly, some dark, some bright, some filled with stars, some empty. Picture the boundaries that keep them apart, forever unreachable, yet forever real. In one bubble, you're here, listening. In another, perhaps the constants were tuned differently, and no listeners arose at all. Both bubbles exist, stitched into the same fabric of inflation, separated but siblings in the great froth of creation. And when you close your eyes, perhaps you can feel the foam around you, not frightening but soft, like the bubbles of a warm bath. Reality, in the level 2 picture, is not a single ocean but a sea of bubbles, each one a world entire, each one a possibility realized. Whether or not we can ever prove it, the thought itself is enough to widen the imagination, to stretch the heart, to remind us that the universe, generous and mysterious, may have made more than one melody. It may have composed an entire symphony of worlds, each bubble a note, each note a song, and our bubble, our song, playing softly here tonight. Tegmark's map of the multiverse does not end with horizons and bubbles. Beyond level 1's distant repetition, and level 2's bubbling variety lies something more intimate and more audacious. He called it level 3, and it corresponds to Hugh Everett's many worlds interpretation of quantum mechanics. Unlike the bubbles of inflation, which may be scattered across unreachable stretches of space, level 3 unfolds right here, in the branching of every quantum event, in the splitting of every possibility. It is not elsewhere, but everywhere. In level 3, reality is not a single thread, but a tree forever dividing. Each time a particle interacts, each time a choice is made, each time a quantum coin is flipped, reality branches. In one branch, you sip tea. In another, coffee. In one, the cat lives. In another, it does not. You inhabit one branch, unaware of the others, but the mathematics of quantum theory allows them all. To soften this, Imagine a great river splitting into countless channels as it approaches the sea. Each channel carries the same water, yet each finds its own course, weaving through sandbars, islands and reeds. From the sky, the delta looks like lace, intricate and endless. That is level 3. Reality as a delta of branching channels, each as real as the next. What is striking about level 3 is that it does not add anything fundamentally new beyond quantum theory itself. It is not an extra hypothesis layered on top. It is simply the mathematics taken at face value. If you accept the equations, the branches follow. Many physicists resist this, preferring interpretations where branches are illusions or where probabilities collapse into single outcomes. But the elegance of level 3 is its simplicity. No collapse, no hidden rules, just branches, forever growing. Then there is level 4, the boldest of Tegmark's proposals. If levels swaying through the 3 still rest on familiar physics, space, time, quantum mechanics, then level 4 leaves even those behind. It suggests that reality itself may be mathematical, that every consistent mathematical structure corresponds to a universe. Not only other regions of space, not only other bubbles or branches, but other logics, other geometries, other rules entirely. In this view, our universe is just one mathematical structure among countless, a single equation in a vast catalogue of equations. To imagine this, think of a library again, not filled with stories but with formulas. Each book is a different mathematics, a different logic, a different framework of rules. Some may be thin pamphlets, simple but barren, incapable of giving rise to complex structures. Others may be thick tomes, brimming with richness, capable of stars, chemistry, and life. Our universe, then, is simply one of the thick books, one of the rich equations that can blossom into galaxies and minds. We live in its story because it is one of the few that can host storytellers. Level 4 is difficult to grasp because it feels abstract. But metaphors help. Picture a vast orchard where every tree grows from a different seed. Some trees are stunted, barely sprouting. Some grow tall but bear no fruit. Others, rare and precious, bloom with blossoms and heavy branches. Each tree is a mathematics. Ours happens to be fruitful, bearing stars and atoms and life. The orchard is endless, but we inhabit one tree, one branch heavy with fruit, one blossom fragrant enough to notice itself. Another image. Imagine a room filled with musical instruments. Some are broken, some cannot be tuned, some produce only dull noise. But a few, when played, create symphonies. The multiverse at level 4 is that room, filled with every possible instrument, every possible tuning. We live inside one of the instruments capable of music. The fact that music exists here is not surprising. It could not exist elsewhere. Critics argue that level 4 goes too far, that it drifts from physics into philosophy. How can we ever test whether other mathematical structures correspond to universes? Perhaps we cannot. But Tegmark's point is not to claim certainty. It is to widen imagination, to remind us that even our most basic assumptions, that space and time are real, that logic is fixed, may be local to our universe. Other universes in other structures may follow different logics, different songs. For us tonight, we need not settle the debate. It is enough to picture the levels as a ladder. On the first rung we find distant galaxies repeating across infinite space. On the second we see bubbles frothing from eternal inflation, each with its own constants. On the third, we stand among the branches of quantum choices, every moment splitting. And on the fourth, we step into a hall of mathematics, every structure alive, every equation a world. The ladder may extend further still, but these 4 rungs already stretch the imagination beyond measure. So as you rest, let the images drift together. A delta of rivers, a library of equations, an orchard of trees, a room of instruments. Picture reality as a tapestry woven not just from threads of space and time, but from threads of logic and mathematics themselves. Somewhere in that tapestry is our patch, our melody, our tree. And though we cannot see the others, the thought of them enlarges the night, turning the silence around you into a choir of unseen worlds. If the multiverse is real, we might ask what evidence it could leave in the fabric of our own universe. The trouble is that other universes, whether bubbles or branches or mathematical structures, may be forever beyond our reach. Their light cannot cross the inflating gaps. Their laws may be sealed behind cosmic walls. And yet, physicists cannot help but wonder if faint fingerprints might linger, written in the oldest, light we can see, the cosmic microwave background. The cosmic microwave background, or CMB, is often called the afterglow of creation. It is the faint, uniform radiation that fills the universe, the leftover warmth from when the cosmos was just 380,000 years old. Before that time, the universe was so hot and dense that light could not travel freely. It scattered endlessly among particles, like sunlight in a thick fog. But as the universe cooled, atoms formed, the fog lifted, and light began its long journey through space. That ancient light still surrounds us today, stretched by expansion into microwaves, whispering the story of the young universe. When astronomers look at the CMB with sensitive instruments, what they see is a nearly uniform glow, like a soft blanket spread across the sky. But it is not perfectly uniform. There are tiny ripples, variations in temperature only a few millionths of a degree, speckles that show where matter was slightly denser, slightly thinner. Those ripples became the seeds of galaxies. Without them, the universe would be empty. They are the first sketches of cosmic structure, drawn in the afterglow. Because the CMB is so sensitive, scientists have searched it for signs of something more. Subtle anomalies that might hint at interactions with other universes. One of the most famous is called the cold spot, a region of the sky that is slightly cooler than expected, larger and deeper than the surrounding fluctuations. Some have suggested that this might be the scar of a collision, where our bubble universe brushed against another in the froth of eternal inflation. If bubbles form endlessly, might they sometimes bump? And if they do, might the impact leave a ring, a bruise, a ripple in the afterglow? For a time, the cold spot was whispered about with excitement. It seemed unusual, perhaps too unusual to be explained by chance alone. Other claims followed. Circles in the microwave sky, alignments of fluctuations called the axis of evil. Each was interpreted by some as possible evidence for the multiverse, a faint echo of collisions beyond our horizon. The thought was intoxicating. Perhaps the afterglow of our universe carries faint shadows of other universes, as if light through a curtain reveals shapes behind it. But science is careful, and patience often dulls early excitement. When the Planck satellite mapped the CMB with greater precision than ever before, the anomalies softened. The cold spot, though real, seemed consistent with statistical noise once larger data sets were analysed. The claimed circles faded. The axis of evil looked less sinister, more like the pattern-seeking tendency of the human mind. It was as if the wallpaper of the cosmos had been studied under a brighter lamp, and the supposed secret patterns resolved into ordinary stains, quirks of randomness. Still, the allure remains. Searching the CMB for hints of other universes is like listening to static on an old radio hoping to catch a faint signal from across the stars. Most of what we hear is noise, hisses of chance, but every so often a note seems to form and the imagination leaps. Even if the anomalies prove illusory, the act of listening teaches us something. It refines our maps. It deepens our understanding of the early cosmos. It reminds us that the universe is still whispering, and we are still learning how to listen. To make this gentler, picture yourself lying beneath a quilt, its fabric faintly glowing in the dark. At first glance it seems smooth, but if you run your hand across it, you feel the tiny stitches, the slight ridges, the places where the weave is thicker or thinner. The CMB is like that quilt, the ancient fabric of the cosmos stitched with ripples that seeded galaxies. Scientists with their instruments are like fingers tracing the cloth, wondering whether some of those stitches tell a story beyond our own patch. Or imagine sitting by a lake at dawn. The surface looks calm, a mirror of sky. But if you look carefully, you see ripples spreading, faint rings from stones dropped long ago. You cannot see the stones now. They're gone beneath the surface. But the ripples linger, carrying traces of past events. The cold spot was imagined to be one such ripple. Perhaps not from our stone, but from another universe's. Whether true or not, the metaphor remains haunting. The search for evidence in the CMB reminds us of both the ambition and the humility of science. Ambition, because we dare to ask if the oldest light in the universe carries messages from realms we can never reach. Humility, because the answer may always be no. The anomaly is always noise. But even then, the attempt is meaningful. It sharpens our instruments, enriches our maps, and deepens our sense of mystery. So as you close your eyes tonight, imagine that ancient light surrounding you, soft and steady, older than any star, older than any galaxy. Imagine its ripples, faint as whispers, carrying the first stories of structure. Somewhere in those ripples may lie hints of other universes, or perhaps only the poetry of chance. Either way, the afterglow is a lullaby, humming across the sky, reminding us that we live in a cosmos stitched with memory, a quilt of light that still warms us. The question of evidence is always the heartbeat of science. It is one thing to imagine countless universes, to speak of bubbles and branches and gardens of laws, but another to ask, how would we ever know? If other universes exist, what signs could they leave for us to find? It is like wondering whether neighbours live beyond the forest. You cannot see them directly, but perhaps you might hear faint music on the wind, or see the glow of firelight through the trees. For the multiverse, those faint hints would have to appear in the fabric of our own cosmos, subtle marks left at the edges of what we can observe. One of the most discussed possibilities comes from collisions between bubble universes in the froth of eternal inflation. If bubbles form endlessly, it seems natural to ask whether they sometimes bump. Imagine a bath filled with soap bubbles. They expand, drift, and occasionally touch. Where they touch, they leave circular marks, distortions on the fragile film. If our universe is such a bubble, then perhaps it has collided with others in its distant past. The scar of such a collision, if it reached us, might appear in the cosmic microwave background as a ring, a subtle bruise in the afterglow of creation. Astronomers have searched for such circles, mapping the sky in exquisite detail. So far, the evidence has not held. No clear, repeatable marks have been found. But the search itself is a reminder that the question can be asked in a testable way. Another kind of evidence might come from statistical anomalies. The CMB, for instance, is expected to have a random distribution of ripples, like the grain of wood or the weave of cloth. If we find large-scale alignments or unusual patterns, it could suggest influences beyond our universe. The so-called axis of evil, an alignment of fluctuations in the CMB, once raised eyebrows. Was it chance, or a sign of deeper structure? Most scientists lean toward chance, but the curiosity remains. Could unusual statistics in the cosmic fabric be a whisper from other realms? There is also the possibility of indirect reasoning. If a theory that predicts a multiverse also explains other observable phenomena, then confidence in the theory, and by extension in the multiverse, grows. Inflation is one such case. It explains why the universe is so uniform, why it is flat, why galaxies could form. Eternal inflation, the version that spawns many bubbles, flows naturally from the mathematics. If inflation is true, then a multiverse may be unavoidable, whether or not we can observe it directly. The evidence is indirect, but it carries weight, like hearing footsteps in the snow and knowing that someone has walked there, even if you do not see them now. But what would decisive evidence look like? That is harder to imagine. Perhaps we might someday detect gravitational waves, ripples in space-time that carry imprints of collisions between universes. Perhaps we might discover patterns in the distribution of galaxies that cannot be explained by a single cosmos. Or perhaps evidence will never arrive, the boundaries between universes sealed forever, leaving us only with inference and imagination. The challenge here is philosophical as well as scientific. Some argue that if we can never in principle detect other universes, then the idea lies outside science. It becomes metaphysics, speculation untethered. Others reply that science has always operated at the edge of the observable. Atoms were once invisible, inferred from chemistry long before microscopes confirmed them. Black holes were once mathematical curiosities, decades before telescopes caught their shadows. If the multiverse explains the constants, the structures, the very fact of existence, then perhaps it deserves a place at the table, even if direct evidence eludes us for now. To make this gentler, think of looking at an old quilt. Most of it is intact, patterned and clear, but at the edges, the fabric frays. Threads stick out, colours blur, the weave loosens. It is at the frayed edges that hints of other fabrics might appear, the suggestion that this quilt was sewn from something larger. Our universe, too, has frayed edges. Horizons, background radiation, statistical anomalies. If other universes have left marks, they will be in those frays. Or imagine walking on a beach after a storm. The sand looks familiar, smooth as always, but scattered here and there are shells, driftwood and strange stones that do not seem to belong. They may have been carried by currents from other shores, tossed here by waves. To an attentive eye, they are hints of a world beyond your own coastline. The search for evidence of the multiverse is like that beachcombing, looking for shells that could only have come from another shore. Whether such shells will ever be found remains uncertain. For now, most of the signals trend toward noise, most anomalies resolve into chance, and yet the act of searching deepens our understanding of the cosmos we can see. It sharpens our instruments, refines our theories, teaches us patience. Even if we never find a scar from another universe, we learn more about our own. So as you settle tonight, think of evidence not as proof, but as possibility. Think of scars in the cosmic afterglow, circles on the microwave sky, shells on a distant beach. Perhaps they are illusions, perhaps they are whispers from beyond, perhaps both. Either way, the search is part of the story, part of the gentle unfolding of curiosity. Science does not always give us certainty. Sometimes it gives us questions that lull us into wonder, questions that stretch our minds just far enough to soften into sleep. Every telescope, no matter how powerful, is like an eye pressed to a window. You see what lies beyond the glass, but only so far. Light fades with distance, horizons intervene. The cosmos places limits on what we can know. And when it comes to the multiverse, those limits are especially sharp. The very definition of other universes often means places cut off from us, separated by inflationary walls or branching quantum histories. They are not just far away, they are causally sealed, beyond any message, beyond any touch. It is at this edge of observation that science and philosophy begin to lean against each other, and where imagination often steps in. Think of standing on the shore of a vast ocean at night. The waves roll in, the horizon is black. You cannot see what lies beyond, but you know there are other shores, other islands, other continents. You trust reason, not sight. For cosmologists, the observable universe is such a shore. We see galaxies stretching to the cosmic horizon, but beyond that lies ocean we cannot cross. If the multiverse exists, it lies across that ocean, unreachable yet not unthinkable. Some scientists, like Paul Steinhardt, argue that this makes the multiverse unfalsifiable. If we can never gather evidence, how can we call it science? It becomes, they say, a story without test, a speculation dressed in equations. For them, the edge of observation is a boundary that must be respected. Theories that cannot, even in principle, be tested, belong outside the laboratory. Others reply differently. They argue that science has always included inference, that unseen worlds can still be real if their effects are felt. Atoms were once beyond observation, yet their fingerprints were everywhere in chemistry. Black holes were once hidden, inferred only from the dance of nearby stars, long before telescopes revealed their shadows. If inflation predicts the multiverse, and if inflation explains what we see, then perhaps the multiverse inherits the credibility of the theory, even if its other bubbles remain forever beyond. It is a subtler standard, not direct evidence, but indirect trust, coherence, explanatory power. Everyday life can illuminate this. Imagine hearing laughter from behind a closed door. You cannot see the people inside, but the sound suggests their presence. Or picture footprints in fresh snow. You did not watch them being made, but you know someone passed. The edge of observation works the same way. Even if we cannot see beyond the horizon, hints and patterns within our universe may serve as footprints, indirect but telling. And yet, there is a kind of beauty in the uncertainty. At the edge of observation, science becomes less about answers and more about questions. It becomes a reminder that we are small creatures with finite tools, peering into an immense mystery. The very impossibility of proof turns the multiverse into a meditation on humility. We may never know for sure, but perhaps not knowing is part of the gift. It leaves room for wonder, for imagination, for stories told softly in the dark. Metaphors help carry this thought. Imagine a child pressing their face to a frosted window in winter. The glass is blurred, the world outside indistinct. Shapes move, but details dissolve. The child asks questions anyway. Who is walking? What is happening? What lies just out of sight? The multiverse is like that view through frosted glass. We can see shapes, mathematical hints, theoretical whispers, but the details blur. We may never scrape the frost entirely, but the asking itself is part of being human. Or imagine an ancient sailor, guided only by stars and currents, sensing lands beyond the horizon. They cannot see them yet, but maps are drawn, journeys attempted, stories told. Some voyages succeed, others fail. The sailor's horizon is not the world's edge, only the edge of knowledge. For cosmologists, the cosmic horizon is similar. It is not the end of reality, only the end of our. Sight beyond it may lie other shores, other universes. Whether we ever reach them or not, the thought reshapes our map of existence. There is also a personal echo here. Each of us lives with horizons. We cannot see beyond tomorrow. We cannot predict every consequence of our choices. We stand at the edge of observation in our own lives, guessing at possibilities, imagining futures, but never knowing until we step forward. In that sense, the multiverse is not so alien. It is simply the cosmic version of what we already live. Mystery beyond sight, possibilities beyond reach, paths hidden by fog. So what lies at the edge of observation? Not certainty, not proof, but possibility. The multiverse may be real, or it may be an artifact of our mathematics. We may someday gather indirect evidence, or we may never know. But tonight it is enough to stand at that edge in thought, to gaze across the ocean of space, to feel the horizon stretching silently away. It is enough to let the mystery rest beside you, gentle and unresolved, a reminder that knowledge and wonder walk together. And as you drift towards sleep, think of that edge not as a barrier but as a threshold. Beyond it, perhaps universes bloom. Beyond it, perhaps silence stretches. Either way, the horizon is wide, the ocean deep, the mystery endless. And you, here, are part of it. A listener on the shore of the infinite. At the heart of science is a principle as old as Galileo's telescope, and as new as the latest particle accelerator. Ideas must be testable. A theory earns its place not simply by being beautiful, but by offering predictions that the world itself can confirm or deny. Paul Steinhardt, a cosmologist who once helped shape inflationary theory, has become one of its most outspoken critics for precisely this reason. For him, the problem with eternal inflation, and by extension the multiverse, is that it stretches science beyond testability into a realm where evidence may never arrive. His challenge is simple and sharp. If the multiverse can explain anything, then it explains nothing. To understand his concern, imagine you're trying to solve a mystery. You find a locked door and you wonder what is behind it. If someone tells you it could be anything at all, the answer is true, but useless. It does not narrow possibilities, it does not guide you. In Steinhardt's eyes, the multiverse risks becoming that answer. A theory so broad that every outcome is permitted, every observation justified after the fact. Why are the constants what they are? Because in some universe they must be, and we are in one of them. Why is the cosmos smooth, or clumpy, or balanced? Because there are universes where it is not, and ours happens to be the one where it is. The multiverse becomes a universal key that unlocks every door, but by unlocking all doors, it stops being a key at all. Steinhardt's critique is not cynical but careful. He reminds us that science thrives on risk, on the possibility of being wrong. If a theory cannot, even in principle, be disproven, then it sits outside science's method. Eternal inflation, he argues, predicts so many universes with so many different properties that it cannot be falsified. Whatever we observe, some universe in the multiverse will match it. That makes the multiverse flexible, but also fragile as a scientific tool. To make this gentler, picture a weather forecaster. If they say, tomorrow it may rain, or it may not, or it may snow, or perhaps be sunny. You cannot fault them for being wrong, but you cannot call it a forecast either. It is true but empty. Steinhardt worries that the multiverse, for all its grandeur, risks being that kind of forecast, covering every possibility, offering no risk, no test, no bite. This challenge has deep philosophical roots. From the beginning, science has sought explanations that do more than fit the data. They must also constrain it, narrowing what is possible, showing why things could not have been otherwise. Newton's laws did not simply describe the motion of planets. They predicted their paths with precision, leaving room for correction but not for anything at all. Quantum mechanics, for all its strangeness, offers probabilities that can be tested. Relativity, for all its counterintuitive beauty, makes predictions we can confirm with clocks on airplanes and light bending around stars. The multiverse, Steinhardt argues, risks stepping away from this tradition. Everyday life offers echoes of this concern. If a friend explains every event by saying, "That's just how it is," you may nod, but you learn nothing. If a teacher says, "Every answer is correct," the lesson dissolves. If a map says, "You can go anywhere," you're no closer to your destination. Steinhardt fears that the multiverse, by explaining everything, explains nothing in particular. And yet, his critique is not without a certain poetry. It reminds us of the boundary between knowledge and imagination. It reminds us that the hunger for testability, for falsifiability, is not a limitation but a strength. It is what keeps science anchored to reality, what ensures that our stories of the cosmos are more than dreams. His challenge is not meant to banish wonder, but to guide it, to remind us that even the most beautiful visions must find a way to meet the world. For us, listening in the dark, his words offer a pause. the multiverse is alluring, filled with images of bubbles and branches and gardens. But perhaps it is also a reminder that our minds are capable of imagining more than we can prove. Perhaps the value lies not only in the possibility of being right, but also in the act of stretching our thought, even if the proof never comes. Steinhardt would caution us to keep one foot on solid ground, to remember that without testability, the multiverse remains a story rather than a science. So tonight, picture the scientist at his desk, chalk dust on his hands, equations spread across the blackboard. He looks at the multiverse not with hostility, but with care, asking, does this theory risk explaining too much? Does it risk slipping from science into philosophy? His challenge is a whisper of caution, a voice reminding us that wonder must walk hand in hand with rigour. And as you drift, think of your own horizons of imagination. There are places in your life where certainty is possible, where evidence guides you. There are also places where mystery remains, where stories fill the gaps. Both have their place. Steinhardt's challenge is not to silence imagination, but to ask us to notice the difference, to let wonder be wonder and science be science, and to rest at the edge where they meet in the quiet balance between proof and possibility. If Steinhardt's challenge is the voice of caution, then others answer with a different melody, that science is not defined only by what can be seen directly, but also by what can be inferred, what can be supported by coherence, and what can be tested indirectly. They argue that the multiverse is not a blank key opening every door, but a framework that, though difficult, can still be judged by its harmony with what we do observe. The debate is not between dreamers and skeptics, but between two traditions of thought, one demanding testability in its sharpest form, the other allowing broader criteria so long as the theory explains, unifies and predicts. Consider how science has often proceeded. Atoms were theorized long before anyone could see them, inferred from the way gases behaved, from the ratios and chemical reactions. Neutrinos, those ghostly particles, were predicted by Wolfgang Pauli in 1930, not because they were observed, but because without them, conservation laws seemed broken. For decades they remained invisible, until detectors finally confirmed their existence. Even black holes began as equations, curiosities in Einstein's mathematics, too strange to be believed. Only later did we find stars orbiting invisible companions, light bending around unseen masses, shadows captured on the Event Horizon telescope. In each case, reality was accepted before it was seen, because the theory worked, because the predictions fit, because the pieces of the puzzle aligned. Supporters of the multiverse argue the same. Eternal inflation, for instance, is not conjured out of desire for multiple universes. It arises naturally from the mathematics of inflation, which already explains the flatness and uniformity of the cosmos we observe. If inflation is right, and if its equations lead to eternal bubbling, then to deny the multiverse is to deny the consequence of the theory we already trust. It is like following a recipe faithfully, watching it yield a cake, and then refusing to believe that the cake must also have crumbs. The crumbs are inevitable. Another criterion is explanatory power. The multiverse may not give sharp, unique predictions, but it helps explain why the constants of our universe seem so finely tuned. Without it, we are left with puzzling coincidences, why gravity is weak but not too weak, why the cosmological constant is small but not zero. With the multiverse, the coincidences soften into context. In a vast variety of universes, we live in one where the tuning allows life. It is not a final answer, but it reframes the puzzle. In science, reframing is often as valuable as solving. Mathematical consistency is another measure. A theory must not only match observation, but also avoid contradictions. Inflation, quantum mechanics, and string theory each point in their own way toward multiplicity. If rejecting the multiverse means breaking the coherence of these frameworks, then perhaps the multiverse earns its place. not through direct proof, but through necessity. It becomes the quiet background that allows the foreground to make sense. To bring this down to earth, imagine you are listening to an orchestra. You cannot hear every instrument individually, but you hear the harmony, the violin's note, the cello's depth, the flute's bright thread, all weave together. You might never isolate each sound, but the coherence tells you they are there. The multiverse in this analogy is not the soloist playing before us, but the harmony we infer, the underlying structure that makes the symphony whole. Or picture a house. You see the walls, the windows, the roof. You cannot see the foundation, buried deep, but the stability of the structure suggests it is there. You may never touch it, but you trust it, because the house stands. The multiverse may be such a foundation, hidden, unseen, but implied by the way the house of physics stands upright. Critics may still protest, and rightly so. They ask, are coherence and explanatory power enough? Do we risk blurring the line between science and philosophy? The answer may be that science is not a single line, but a spectrum. Some theories begin in shadow, supported by inference, later confirmed by light. Others remain forever in shadow, never fully testable. Where the multiverse falls is not yet clear. But those who defend it argue that we should not dismiss it too soon. History is full of once unseen realities that turned out to be real after all. For us, lying awake tonight, the debate itself is soothing in its honesty. Science is not monolithic. It contains voices of rigour and voices of imagination, sometimes intentioned, sometimes in harmony. The criteria we use, testability, coherence, explanatory power, are not rigid gates but tools, helping us decide what belongs on the frontier of thought. The multiverse may live on that frontier, neither proven nor dismissed, a possibility that stretches our imagination while reminding us of the care science requires. So picture again the orchestra. Some instruments are clear, their notes ringing, others are softer, buried in the harmony. You may not hear them directly, but without them, the music would falter. The multiverse may be one of those hidden instruments, inaudible alone but essential to the song. Or picture the foundation of the house, unseen yet steady. Or the wind-shaping trees, invisible but evident in the bend of the branches. Science has always been willing to trust the invisible when the visible demands it. Perhaps the multiverse is another such case, unseen, but whispered in the way the cosmos stands. As you drift, let these thoughts soften into quiet. Evidence may come, or it may never arrive. The criteria may shift, or they may remain stern. But in either case, the conversation is itself a kind of evidence, not of other universes, but of the human spirit, always reaching beyond horizons, always asking what lies beyond the edge of sight. We have wandered through horizons, bubbles, branches and gardens, and now we reach the quietest question of all. What would it mean if the multiverse were real? Not what equations it would confirm, not what data it would explain, but what it would mean for us, for our sense of place, our feeling of uniqueness, our search for meaning beneath the stars. For much of human history, the universe was thought to be a stage built for us. The stars were lanterns hung in a dome, the earth the solid centre. Then science arrived with its widening horizons. Copernicus moved us from the centre of the solar system. Galileo's telescope showed moons orbiting Jupiter, proof that not everything circled Earth. Later, we learned that the Sun is one star among hundreds of billions in the Milky Way, and the Milky Way one galaxy among trillions. Each step was humbling, stripping away centrality but expanding wonder. The multiverse, if real, is simply the next step. Not one universe, but many, not one stage, but countless theatres, each with its own play. What does this do to our sense of significance? Some might say it diminishes us. If there are countless universes, then ours is but one bubble in the bath, one patch on the quilt, one branch in the tree. Why should it matter? But another view is gentler. Our universe is not less because there are many. It is simply part of something larger. A snowflake does not lose its beauty because billions fall in a storm. A note does not lose its sweetness because it is part of a symphony. Our universe, our lives are precious precisely because they are one expression among many. To soften this thought, picture yourself walking through a meadow at night. Fireflies blink around you, dozens, hundreds. Each glimmer is brief, but beautiful. You do not need one firefly to be the only light to find wonder in it. You see the meadow alive with countless sparks, each adding to the beauty of the whole. If the multiverse is real, then our universe is such a firefly, one spark among many, glowing for its moment, part of a greater meadow of existence. There is also the question of possibility. If countless universes exist, then every arrangement of matter, every unfolding of laws may be realized somewhere. The possibilities of life, of beauty, of tragedy, of invention, of silence, all of them bloom across the multiverse. This can feel overwhelming, but it can also be freeing. It means reality is not a single fragile thread, but a vast tapestry, strong because it holds every pattern. Our thread may be small, but it is woven into the whole, impossible to tear from it. And then there is the question of perspective. In an infinite multiverse, the fact that you exist at all is astonishing. Against the silence of sterile universes, against the vast deserts where nothing forms, you live in one of the rare places where stars shine steadily, where chemistry holds, where complexity rises from simplicity. You are part of a cosmos tuned enough for life, and that alone is extraordinary. The multiverse does not erase this miracle. It multiplies it. It says, not only here, but there too, existence sings. Not only in this key, but in countless others, melodies play. Critics sometimes say the multiverse cheapens our uniqueness. But uniqueness is not only measured by being the only one. It is also measured by being yourself, irreplaceable even among many. You're not diminished because there are billions of humans on Earth. Your life is still yours, singular, unrepeatable, even if others live too. In the same way, our universe is still itself, with its galaxies, its history, its listeners drifting into sleep. It matters not because it is alone, but because it is here. To bring this closer, think of a garden once more. You walk among flowers. Some are red, some blue, some gold. The fact that there are many does not make the red rose less beautiful. It makes the garden richer. The multiverse, if it exists, is that garden, and our universe is one bloom among countless others. It is not less for being one of many. It is more, because it is part of the whole. And what about meaning? If there are infinite universes, does anything matter? The answer may be the opposite of what we fear. Meaning is not erased by multiplicity. Meaning is created in the moment, in the life lived, in the connection shared. The multiverse does not change the fact that you feel, that you wonder, that you love, that you rest. It only says that such things are possible not only here but in many places, and that should not make them less but more abundant, more possible, more wondrous. So tonight, as you let your thoughts drift, do not imagine the multiverse as something cold or distant. Imagine it as a meadow of fireflies, a garden of blooms, a symphony of notes. Imagine that our universe is one spark, one blossom, one note among countless others. And then feel the comfort of knowing that even if we are small, even if we are one among many, we are still part of something vast, something beautiful, something beyond measure. We have wandered far tonight, from horizons wrapped in mist to bubble baths of universes, to forests of branching choices, to gardens of laws and orchards of mathematics. We have touched the edges of evidence, heard the debates of scientists, and drifted into the meaning of it all. Now, in this last session, we step back. We let the images settle like snowflakes falling quietly, covering the ground with stillness. We let the multiverse remain what it is, a dreamlike possibility, a reminder that reality may be vaster than we can ever hold, and yet tender enough to cradle us here. Think of all the metaphors we have gathered. The cosmic quilt stitched with patches of universes, the frosted window blurring what lies beyond sight, the orchard of trees, each seed a cosmos, the fireflies glowing across a meadow, each spark another world. These are not proofs. They are lanterns, gentle lights to guide imagination. The multiverse may or may not exist, but the act of picturing it enlarges our minds, widens our hearts, and gives us a sense of belonging to something immense. It is easy, in daily life, to feel enclosed. Rooms have walls, schedules have limits, worries keep the mind in narrow circles. But then comes a thought like the multiverse, and suddenly the walls melt away. Suddenly, you're not only in a room, but in a universe, and perhaps even in one universe among countless others. Your breath becomes part of a cosmic song, your choices branches in a great forest, your presence a spark in an endless meadow of fireflies. To carry that thought is to feel both small and infinite, both fragile and enduring. As we close, let us think of the multiverse not as a theory to be solved, but as a lullaby. It says, there may be more, always more horizons, more bubbles, more branches, more blossoms. It says, you are not confined, you're not alone. It says, existence is abundant, generous, beyond measure. Even if we never prove it, even if evidence never arrives, the image is enough to remind us that reality is always richer than it appears. Imagine now that you're lying beneath a quilt. Each patch glows faintly, like a universe stitched in light. You trace the seams with your fingers, but the quilt stretches farther than you can see. Somewhere on it is our patch, warm and bright, with galaxies and stars. Beyond it are others, unseen but real, glowing in their own patterns. The quilt covers you, not heavy but gentle, wrapping you in infinity. Or imagine that you're walking by a quiet lake at dusk. The water is still, the sky deepening. You toss a stone, and ripples spread across the surface. They fade, but for a moment the whole lake carries their memory. The multiverse is like that lake, full of ripples, full of echoes. You cannot see all the stones, but you feel their presence in the patterns on the water. Science may someday tell us more, or it may not. The multiverse may remain forever at the edge of imagination, a possibility rather than a certainty. But certainty is not always necessary. Sometimes the value of an idea lies not in proof, but in perspective. The multiverse, real or not, teaches us humility. It reminds us that the universe is not ours alone. It invites us to wonder, to dream, to listen. And so, we end where we began, with a quiet question. Are we one bubble among many? Are we one patch in a quilt, one firefly in a meadow, one note in a symphony? Perhaps, perhaps not. But tonight, as you rest, it does not matter. What matters is the feeling of vastness, the comfort of possibility, the gentle rhythm of wonder. So close your eyes. Let the images float, bubbles rising, forests branching, flowers blooming, stars shining. Let them blur together into a soft haze, like dreams you forget upon waking. Let the multiverse be what it is. A story whispered across the night, a song hummed in the background of existence, a comfort against the silence. And if you drift into sleep, let that sleep be another universe, another branch, another bubble in the bath. Let it carry you gently, as the cosmos itself carries us into the quiet unknown. For whether the multiverse is real or not, the fact remains. Here you are, alive in this universe, listening, breathing, wondering, and that in itself is miracle enough.